So this is question number 13 in multiple choice question, how to draw the graph of all the trigonometric functions. So this question is related to how to draw the graph of all trigonometric. This is question number 13 in end of coverage. So I want to discuss all the type of graphs here with you. So look at this question number 12 here, how we are going to draw the diagram of minus 2 cot x. So firstly we need to draw the graph of minus 2 tan x. So firstly think about this. So here this number tells us here stretch and compress. It is a minus 2 is minus 2, absolute value of minus 2 is 2, which is greater than 1, which is greater than 1. So this is your stretch vertically. So this will stretch vertically. Tan x and cot x, no amplitude. There is no amplitude in tan x and cot x. Always remember. So let me see how we are going to draw the graph of this. So what do you need to do here? First is this value. What is the coefficient of x? What is with x? With x is there is no number, that means 1 is there. So we have here minus 2 tan 1x. So first you need to find out the asymptote, right? This value you will make to equal to pi by 2, because original tan x has the asymptote pi by 2 and minus pi by 2. Pi by 2 means 90, 90 and minus 90. So make this value 1x equal to 1x is equal to 90 degree. So this is the value of this will give you your first asymptote. So my first asymptote is x is equal to 90 degree. So where will be x 90 degrees? So here will be x 90 degree. Let me draw this with red color. So this is my first asymptote. One side is 90. This is 90. And second side we have minus 90. Minus 90 is here. This is minus 90. So now, so similarly, so what is the difference between these two? 90 and minus 90, 180. So where will be the next asymptote? Add 180 here. 90 plus 180, you would reach to 270. So second asymptote on the right side is at 270. Why 270? Because the difference here 90 from minus 90 to 90 180. So you have to add 90 plus 180 is 70. So these are your asymptote on the left side and right side. One more if you want to draw. If you want to draw minus 270, you can draw. Firstly, I'm drawing the graph of minus 10x. Sorry, 10x. So now what we have now, what is the graph of 10x? What is the graph of 10x? 10x graph is we have like this. So this is the graph of and these are the intercepts. These are the intercepts. This is the graph of 10x. But here you have minus is there, minus, so it will be a reflection. There is a minus here. So what will be the reflection? So this is what the blue lines represent, the graph of minus 2 tan x. But what will be your the graph of minus tan x? So that will be opposite to that, the green one. So green one is the graph of minus 2 tan x. So this is the graph of minus 2 tan x, but they are not asking tan x. The blue line is representing tan x minus 10, 2 tan x, green line representing minus 2 tan x, but they're asking about cot. So where will be cot now? Always remember the intercept in tan x. These are the intercept I'm showing with the black this. So these are the intercept for tan x and minus 2 tan x. This will become asymptote for cot, the intercept, the black point. So these are the asymptote for cot. So I will draw the black lines. I will draw the black asymptotes here, black broken lines here also. Okay, let me show you so that you can make the difference. Let me make the dark points, dark lines. So these are the asymptotes 180. Then next will be passing point is y-axis 0. Then next will be 180. So black line representing minus 180, 0, 0 means y-axis, and other one is your 180. So now you can draw the graph. Let me choose. So this, you know that the graph of and this will become the intercepts, x-intercept for cot. So cot graph is like this. Start from one black asymptote to other black asymptote. This is the red graph, is the graph of cortex, but I need the graph of minus cortex, so that will be the reflection. So I will choose the another color. So okay, first I have, this is the graph of red one, is the graph of two cortex, but I need the graph of minus, so reflection of red. So what is the reflection of red? Let me choose the other color. So reflection of red is this. So this is the answer of this, which I'm drawing with the orange color. Rest of the graph, if you want to delete, you can delete. You can delete green one, you can delete red one, you can delete blue one. So what we are left with, the orange one. Orange one is the graph of minus 2 cortex. If I give you the little bit idea again, so if this is your, let me choose the other color. So here, if the simple this, here we have y-axis and x-axis, and this is my first asymptote. You can see the black line here, the y-axis. Other one is 180, so here is 180 minus 180 minus pi, and here is 180 positive. Then you can draw the asymptotes here. Even this is also asymptote. I'm drawing the graph, the original graph, the orange one, which is in this, which I'm showing here, the orange one. So I'm showing this separately here. So this will be, so orange graph is, you can see the orange graph is, and this is the midpoint. So the orange graph will be like this. This is the graph of minus 2 cortex. This one, because in this I have drawn all the graphs. So separately, if I take only the orange one, so it will be like this. So what are the asymptotes? 180 degree. And what is the difference? If you see the difference, between the 180 180, because this is 180, this is 180, so 180 180 is coming. Next is first asymptote positive side 180, so 180 plus 180 360. So positive side 180 degree asymptote, then we have 360 degree, then 360 plus 1, you can continue like this. So that means this is 1 pi, this is 2 pi, next will be 3 pi, and so on. These are the asymptote. And what are the intercept here? What is here between 0 and 180? 90 and minus 90. So what are your asymptotes? Positive side 90, then next will be add 180, so this is 270, again add 180, so you can so on. These are your x-intercept, and these are your asymptotes. So this is how we draw the graph of minus 2 cortex. Look at the question number 11. Again, I'm going to discuss the graph of cot 2x. So just what I told you first step. Just always remember, for tan and cot, write this value equal to 90 degree. So half x is equal to 90 degree. Find the value of x, multiply by 2 here, multiply by 2 here. So 2 and 2 cancel out, so x will be equal to 180 degree. So my asymptote will be minus 180, then 180, then again you add 180, 360 degree. So these are my asymptotes, vertical asymptotes. So these are my, and so on. We'll continue this left side, right side, and left side. So let me draw these. So these representing my asymptotes. So these are the asymptote for tan x, not for the cot x. But this will become this. These are the asymptote for tan x, but this will be the x-intercept for uh, cot x. So look at here. Firstly, I'll show you. So I will show you. This is 180. This is 180 here. This is 180. Then this is if I show you here, this is minus 180. This is for cot, but he's not asking the cot here. He's not asking the cot. These will become 180 and minus 180 will become here the x-intercept. So these are the asymptote for tan x, not for cot x, for tan half x. Here, what is the meaning of half? Half means horizontal stretch or horizontal compress. So because this is a between 0 and 1, half is between 0 and 1. So this will be a horizontal, this will be here, it will be a horizontal stretch here. Horizontal stretch are the conditions I have told you. So these are the asymptotes for tan x, not for the cot x. So these will be, so I will delete these lines. So these will be the, okay, leave it as it is. So these will become the x-intercept. So these are the x-intercept for cot. So what I will take now, so so this is the graph of tan x. This is the graph of tan x. So this is the passing point. This is x-intercept for tan x. But this line will become asymptote for cot. So I am interested in these line. So I will draw only these lines. So I will delete the other lines. Let me take. So I will not take for tan x. I need to take for cot x. So cot x, where will be cot x? Cot x will be, this is the asymptote for cot x. This one is the asymptote for cot x, and next will be minus 180, and this will be, next one is here and here. Let me take the graph again, because I made little mess in this graph. So look at here. Let me take the graph again. So this is the graph. Let me make it this one a little large for you so that you can understand better. So look at this. So as I told you, 180 and minus 180 are the asymptote for tan, but this will become x-intercept. So these are asymptote for tan x, but for cot x they are x-intercepts. X-intercepts for cot half x. So 180 is here, minus 180, minus 180 is here. And first asymptote is y-axis. This is for cot, and other one is between, and other one will be here, because the midpoint is this one, and other one will be here. So what is your cot x? Cot half x. You know that tan x is like this. This is tan x, but we are not interested in tan x. We are interested in cot x. So cot x will be like this. It is not negative. It is, so the flexion will not be there. Start from one asymptote, and it goes to the close to the other asymptote. So this is the graph of cot half x. And what are the asymptotes? Asymptotes are 0, then we have 360, and this side we have minus 360, right? So this is the difference between cot x, and I can show you this. I can show you in Desmos. Let me take you to Desmos. Let me draw the graph of, and this, there is the graph. So here, if I'll show you cot half x, see here cot half x. So I will write here 1 over 2, 1 divided by, wait, I need to write in bracket. So bracket 1, you can say x over 2, x divided by 2. So you can see, let me make this graph like this. This is a graph of this, and you can see this point. What is this point in the pi form? If I'll take minus 180 and this is positive 180. So these are my x-intercepts, and you can see the graph which I have drawn. This point is minus 180 0, that means minus pi and 0, and this will be 180 and 0. 180 means pi 0. The same in the Desmos, you can check minus 180 and 0 and 180 and 0. So this is how we draw the graph of cortex. If still you find any problem, let me know. Now third graph is again cortex. So look at here, the first step, as I told you, 2x is equal to, whenever tan or cot is there, always write this value is equal to 90 degree. So divide by 2, divide by 2, so x is 45. So this is my asymptote for tan x, but x intercept for uh, asymptote for tan x, but x intercept for cot x. So 45 and other side will be minus 45. So these are the intercepts for cot. And for tan, again I'm repeating, for tan it is asymptote, for cot it is uh, x-intercepts. So 45, difference between these two is 90. 90 plus 45 is 135. 135 plus 45 is 180. So these are my intercepts. So let me draw the intercept first. So let me take this graph a little bit large. I'll make it for you so that you can understand better. So what will be my graph? So it will be 45 between 0 and this 90. So here we have taken, so this is 0, between them is 45 is here. So this is 45, then 45 plus 90, between them there's a 135, and we have next is, so these are, so that means my first asymptote is always in cortex. First asymptote is y-axis, next one is 90. 90 plus 90, 180, right? So similarly here you can draw minus 90. So where will be minus 93 boxes I'm counting here? So 3 boxes, 1 2 3. This is your minus 90, and this is your minus 180. And here these are the intercept, 45 here, and this is minus 45 between them, and between them is minus 270. So what is the graph of cot 2x? Easily you can draw like this. Curves are not so good, but you can draw like this. Just you should have the idea about this. And here is also, you can draw like this. You can draw, this is the graph of cot 2x. So here is 2, because of this 2 is greater than 1. This is horizontal compress, remember. So if you see that it is a compress, horizontally compress, I'll show you in the Desmos. So this is the graph of this, and these are the x-intercepts. And what are the asymptotes? You can see this is 90 and this is 180. 90 asymptotes are 90, 0. You start, always got start with 0, 0, 90, then 180, 180 plus 90, 270. So all these are your this asymptote. This is how we are going to do this. This will be not 180 here. This will not be 180 here. 45. 45 plus 90, 135. 135 plus 95 is 225. So 225 is your intercept here. You can check. So this is your 45. Then plus 90, 135. And next one will be 225. If you want to check in Desmos, you can check. Let me take you to a Desmos. So if you see, let me show you here. Cot 2x. See, now the green graph is our answer. Green graph, you can see the intercept. So here, it is more compressed. So it is more compressed horizontally, right? It is more compressed here, and these are our pi by 4 minus pi by 4, and you can say 3 pi by 4 means 135. 135 plus 90 is 225. So these are the asymptote, the green one. And if you see the blue one is more stressed, horizontally stressed, the blue one, but the green one is horizontally compressed. So any number here, any number written in here with x, that tells us horizontal stretch and compress. If it is greater than 1, horizontal compress. If it is between 0 and 1, if any number is between 0 and 1, then what do you say? Any number, I'm writing x or any value between 0 and 1, then we say that vertical compress. But in the number in the front, opposite to that, that is a vertical stretch and compress. So this is how we draw the graph of cortex 3. Question done. So try from your side. If there will be any problem, let me know. Next we have, according to the end of coverage, if you see question number 789, 789 is related to cosec. So it's very easy, not so difficult. For cosec, cosec is the reciprocal of sine. So let me discuss these questions. How to draw the graph of cosec now. Let me take this question on my screen. So let me try firstly this question number 7. Then I'll do question number 8 for cosec. And third one you can try from your side. So how to draw this graph? Let me take these values here because so firstly I'm going to draw the graph of question number 7. Let me make this graph large for you so that you can understand more. Okay. So look at here. Here we need to draw the graph of y is equal to sine 3 over 4x. You know that here's a 1. So amplitude is 1 and this is the value of b, which is 3 over 4x. And you know that what is the formula of the period? Period for this is, don't write here x, only 3 over 4. So period is 360 over b, absolute value of b. So period is equal to 360 over b, b is 3 over 4. And 4 will go up, divide by 4, so 4 will be multiplied here, 3 over 4. So you can divide them. So this will become 12, 120, 120 into 4, 480. So this is the period here. So now we have to see where we have the period now, right? Let me draw this graph by my answer. I'm not using this graph. So this is 360 over b, 360 over 3 over 4. 360 divided by 3 is 120. 120 divided by multiplied by 4 is 180. So it's easy, not so difficult for sine. So look at the shape of sine. First we need to draw the graph of sine. So now after finding out the period, divide this into 4 pieces. 4 pieces means divided by 4. 480 divided by 4. How much? 480 divided by 4 is 120. So first one is 120. Then we have 120, 120 plus 120, 240. 240 plus 120, 360. And 360 plus 120 is 480. So you have to divide in 120 plus 120 plus 120. Same way if you want to do this side. So if you want to take more points, you can take. Now you know the graph of sin x. So what is the shape of sin x? 240. Amplitude is 1. So height should be 1 unit up and 1 unit down. So let me draw the graph of sin x. So what will be sine x graph? Sine x graph goes like this only. I will draw one cycle. So sine graph will go like this, up, and from here it will take the turn, and I'll draw the one cycle only, and here this is the graph of sine x, but let me see, the curves are different, so looking different, so I need to take exactly one is up, one unit up, and one unit down. So this is the graph of sine x. If you want to continue further, so this will be like this is the graph of sine x. So what do you need to do now? Draw the asymptote here. Draw the asymptote here. One asymptote already we have, y-axis already have. Other asymptote is here. Other will be here at 240. So these are the asymptotes. Why my asymptotes are not straight? So I'll make it straight. So what is the shape of? What is the shape of? So you can take some points here. This point, and this point. So your cosec will be this one. Just go and draw a upward parabola here. Here you will draw downward parabola. Similarly, you will draw here downward parabola. So this is the graph of this. This is the graph of cosec 3 over 4x. So what is this point? This point is basically x is 120 and up is 1, 120 and 1. This one is minus 120 and down is minus 1 because in front of minus 1. Similarly, this is 360 and down is minus 1. So this is the graph of cosec x. Let me see this question, how this will make the sense in the Desmos. Cosec 3 over 4x, let me show this graph here. So I need to delete this. So cosec 3 over 3x you can write and divide by 4. So you can see, just I want to show you these points. 2 pi means 360, I drawn only 3. 2 pi by 3, 2 pi by 3 means 16 to 2 minus 120 and 1. This is 360 and 1, and this is, I'll take this picture so that we can compare. So look at here, whatever the graph I have drawn here. So what are the intercept I have taken? 121. 120 means 2 pi by 3. What is the meaning of minus 120? Minus 1 minus and minus 1. And next one is 2 pi and minus 1. 2 pi minus 1 is 360 minus 1. So this is how we draw the graph of cosec 3 4x, 3 over 4x. Let me draw one more graph. I'm deleting this so you can save for later. Let me draw the question number 8 now. Question number 8 is y is equal to cosec 3x. Same steps. Period is 1. So amplitude is 1. B is equal to 3 and period is equal to 360 divided by B is 3, divide them 120. So period we will divide into four parts. So 120 divided by 4 give you 30 degree. So let me draw the graph of this. This is your y-axis. This is your x-axis. And I need to take some equal points here. So I'll start with 30. So 30 plus 30 60, 60 plus 30 90, 90 plus 30 120. Same way one cycle you can take this side, minus 30 minus 60 minus 90. So this is 30 60 degree 90 degree 120 degree. So again we will draw the graph of sin x first. So sin x and amplitude is 1 unit, 1 unit up, 1 unit down. So sine graph I'll draw. Sine graph will go like this, and then this. Similarly, it will, if you take one more cycle here, it will go like this. So now you can draw the asymptote. Asymptote asymptotes are asymptotes will be, I'm drawing with the broken line. Second one is here. One already, the y-axis is already asymptote for this. So now I can draw. So here's the point. One point is here. One point is here. This is your minus 30. So now you can draw the graph of cosec. One parabola up, one parabola down, and similarly this will be down. So this point is 30 and 1. 30 means pi by 6 and 1. This point is 90. 90 means pi by 2 and down is minus 1. This point is minus 30 minus pi by 6 and minus 1. In front of minus 1, this is minus 1. So this is the graph of this. Let me check in the Desmos quickly. So Desmos, now we just need to take 3x, that's it. So you can see these points, just I want to show you only one cycle. So this point you can see pi by 6 and 1, this is pi by 2, this is, I just drawn these three parabola shape. So let me show you here, we will compare with our graph. So look at this, look at this, all are same, pi by 6, pi by 2 minus 1 and pi by 6. So this is all about cosec x. Then we learn about sec. So there are three questions. So on the multiple choice question, but I'm discussing only three because all are same. So firstly, I'm going to discuss the question number 15. So y is equal to secant 4x. You know that secant is the reciprocal of cosine. So now you can say this, firstly amplitude is 1 and b is 4 and period is same just like sine, 360 over b. So 360 over 4 is 90. Same, we will draw this graph. This is y-axis, this is the x-axis, and then divide 90 with 4. If you divide 90 with 4, it will be 22.5. So 22.5, then plus 22.5, 45, then this number, and 45, 45 plus 45 plus 22.5, 67.5, and next number is here. So this is your 22 and a half, this is 45, this is 67.5, and this is 90 degree. If you want to take one more point, you can take. And amplitude is given 1, so 1 is the height. So you can, you know that how we draw the graph of cosine. Cosine graph start from the up. So from 1, it will pass through this. And this is the one cycle complete. If you want to go further, you can go here. If you want to come here, it's okay. So this is minus 225, and now we can draw the asymptote. So you can do this. This will, if you want to show, this is 112.5 because we are adding 22.5, 22.5. Now draw the asymptote. This curve is a little bit large. Let me make this down a little bit because it is going up than 1. So make this little bit down here because it should be in this range. So now you can draw the asymptotes. So one asymptote is here, one asymptote here, and one asymptote here, This is a little bit open, but they should be same, and one asymptote here. Now you know how to draw the parabolas. One point is here, one point is here, one point you can take here. So draw the parabolas now. So parabolas are upward parabola here, downward parabola here. Again we have upward parabola. So just I want to show you these points. So this is 90 and 1, 90 and 1, 90 means pi by 4 and 1, pi by 2, sorry, pi by 2 and 1, and this is 45, 45 means pi by 4 and minus 1, down is minus 1 because this is in front of minus 1, and this is 0 and 1. So this is the blue one is the graph of secant 4x, and the red one is cosine. So first you need to draw the graph of cosine. So look at this secant 4x graph on Desmos. If I'll show you this secant 4x. So what are the points? 0, 1, pi by 2 and 1, 0, 1, and I have drawn this also. I have drawn this. So you can check 0, 1, 91, 45 and minus 1. The same thing. That means our graph is correct. So this is the graph of secant 4x. 3 secant does not make any difference because here's 1. B is 1. So you can do 360 divided by 1 is 360. So 360 will come period. So 360 divided by 4, so it will be 9. So in place of this, there will be 90, 90. So this is the same. You can try from your side. That's it. So there are 3 questions. So on the multiple choice question, but I'm discussing only 3 because all are same. So firstly, I'm going to discuss the question number 15. So y is equal to secant 4x. You know that secant is the reciprocal of cosine. So now you can say this, firstly amplitude is 1 and b is 4 and period is same just like sine, 360 over b. So 360 over 4 is 90. Same, we will draw this graph. This is y-axis, this is the x-axis, and then divide 90 with 4. If you divide 90 with 4, it will be 22.5. So 22.5, then plus 22.5, 45, then this number, and 45, 45 plus 45 plus 22.5, 67.5, and next number is here. So this is your 22 and a half, this is 45, this is 67.5, and this is 90 degree. If you want to take one more point, you can take. And amplitude is given 1, so 1 is the height. So you can, you know that how we draw the graph of cosine. Cosine graph start from the up. So from 1, it will pass through this. And this is the one cycle complete. If you want to go further, you can go here. If you want to come here, it's okay. So this is minus 225. And now we can draw the asymptote. So you can do this. This will, if you want to show, this is 112.5 because we are adding 22.5, 22.5. Now draw the asymptote. This curve is a little bit large. Let me make this down a little bit because it is going up than 1. So make this a little bit down here because it should be in this range. So now you can draw the asymptotes. So one asymptote is here, one asymptote here, and one asymptote here. This is a little bit open, but they should be same, and one asymptote here. Now you know how to draw the parabolas. One point is here, one point is here, one point you can take here. So draw the parabolas now. So parabolas are upward parabola here, downward parabola here. Again we have upward parabola. So just I want to show you these points. So this is 90 and 1, 90 and 1, 90 means pi by 4 and 1, pi by 2, sorry, pi by 2 and 1, and this is 45, 45 means pi by 4 and minus 1, down is minus 1 because this is in front of minus 1, and this is 0 and 1. So this is the blue one is the graph of secant 4x, and red one is cosine. So first you need to draw the graph of cosine. So look at this secant 4x graph on Desmos. If I'll show you this secant 4x. So what are the points? 0, 1, pi by 2 and 1, 0, 1, and I have drawn this also. I have drawn this. So you can check 0, 1, 91, 45 and minus 1. The same thing. That means our graph is correct. So this is the graph of secant 4x. 3 secant does not make any difference because here is 1. B is 1. So you can do 360 divided by 1 is 360. So 360 will come period. So 360 divided by 4, so it will be 9. So in place of this, there will be 90, 90. So this is the same. You can try from your side. That's it.